a present to buy my friend. We just came back from an adventure.
Oh, why, hello there. You've come to the right place. This is Archimedes, Antiquities, Athletics, and Abstracts, and I'm pleased to welcome you. We have plenty of things for you to buy here. I am a mathematician. I offer my services in math tutoring as well, so if you need help in your classes... Anyway, perhaps I can interest you in some pie. They're in back order because I am the first to approximate the value of them. I use the method of exhaustion by drawing a larger polygon outside a circle and a smaller polygon inside the circle. As the number of the sides of the polygon increases, I find a more accurate approximation of a circle.
Ooh, I love food, but my friend doesn't. What else do you have?
Oh, I see. Well then, perhaps I can interest you in this antique. It's the very bathtub that I discovered buoyancy and the theory of displacement in. Oh, I remember the very day I discovered it. Eureka! Eureka! Oh, yes. Well, getting back to business, if your friend enjoys reading, I would recommend him buying the Archimedes palimpsest. It's a collection of treatises I wrote, explaining numerous mathematical principles I've come to discover. My first is On the Equilibrium of Planes, 2 volumes long. It explains the law of the lever, and I used it to calculate the areas and centers of gravity of various geometric figures. My next work was on spirals. In this, I defined what is now called the Archimedean spiral. It is an early example of a mechanical curve, which is a curve traced by a moving point. My next is on the sphere and the cylinder. This is my most proud achievement. I prove that the sphere will have exactly 2/3 of the volume and area of the cylinder. A carving of this proof is to be on my tomb. My next is on conoids and spheroids. The next one I have is on floating bodies. It's 2 volumes long. In my first treatise, I spelled the law of equilibrium of fluids. I proved that the water will adopt a spherical form around a center of gravity. It was an attempt at explaining that the Earth is round. The second part was a calculation of the equilibrium positions of sections of paraboloids. It was an idealization of the shape of ships' hulls. Next is the quadrature of the parabola. In this I proved that the area enclosed by a parabola in a straight line is 4/3 multiplied by the area of a triangle with equal base and height. Next we have the stomachion. This is a Greek puzzle similar to a tangram. In it I calculate the areas of these various pieces. It was an attempt to determine how many ways the strips of paper could be assembled into the shape of a square. It is my way of using combinatorics to solve a problem. Next, we have the cattle problem. I wrote a letter to the scholars in the Library of Alexandria who questioned the importance of my work. I challenged them to count the numbers of cattle in the herd of the sun by solving a number of simultaneous Dipole-Fatine equations. Next is the sand reckoner. In this treatise, I count the number of grains of sand that will fit inside the entire universe. By using a system of numbers based on powers of the myriad, I was able to come to a conclusion. Next and last is my method of mechanical theorems. In it I use infinitesimals and show how breaking up a figure into an infinite number of small parts can be used to determine its area or volume.
Well, I don't know. He might like that. Do you have anything cool and fun to play with?
I didn't invent a death ray of sorts because you seem a little young for that. Perhaps I could interest you in a collection of polygons that I discovered, 13 in number. They're contained by both equilateral and equiangular, but not similar polygons. Our first figure is the truncated tetrahedron. It's a figure of 8 bases being contained by 4 triangles and 4 hexagons. This is a cuboctahedron. 3 figures of 14 bases are contained by 8 triangles and 6 squares. This is a truncated cube, the third by 8 triangles and 6 octagons. This is the Rami cubooctahedron, 2 figures of 26 bases, which are contained by 8 triangles and 18 squares. Our next is the truncated cuboctahedron, 12 squares, 8 hexagons, and 6 octagons. This is the icocytodecahedron. This is 3 figures of 32 bases, contained by 20 triangles and 12 pentagons. Our next is the truncated icosahedron, 12 pentagons and 20 hexagons. This is the truncated dodecahedron, 20 triangles and 12 decagons. Our next is the snub cube. One figure of 38 bases, which are made of 32 triangles and 6 squares. This is the rhomboedecahedron. 2 figures of 62 bases. The first contained by 20 triangles, 30 squares, and 12 pentagons. This is the truncated icosahedron. 30 squares, 20 hexagons, and 12 decagons. And our last, the snub dodecahedron. A figure of 92 bases contained by 80 triangles and 12 pentagons.
Ooh, these look like fun.
No, don't play around with those. Oh!
I'll take it. That was so much fun. You're the best, Archimedes.
Mm-hmm.